Hi everyone. So today we're going to go into the world of the third dimension in geometry, and we're going to be discussing prisms. And so far this year we've spent actually a lot of time working on one-dimensional figures like a segment. Okay, so a segment is one-dimensional. And then in the most recent unit we were looking at squares and rectangles, which were two-dimensional. And today we're going to be looking at prisms, which are three-dimensional figures. Okay, so let's look at some definition of things that we need to know. Prisms falls into the category of something called a polyhedron. A polyhedron is a solid, which means a three-dimensional figure, like the ones on the lower part of the page. A three-dimensional figure with flat polygonal edges. Faces. So flat polygonal faces. The word polyhedron, poly actually is it comes from the word many, and actually hedron means faces. So a polyhedron is many faces. So a prism is a polyhedron. It's a polyhedron with two bases that are identical. Two bases that are identical. And rectangular faces. So if you look at these prisms, now you might not necessarily see it with the rectangle, but these two right here are the bases, and then everything around it are the rectangular faces. This prism, you see the two identical bases are triangles with rectangles as the faces. This particular one is a pentagon, so the bases are pentagons, and then a hexagon. We name prisms by their base. So this first one would be a rectangular prism. A rectangular prism. And this would be a triangular prism. And then we have a pentagonal prism. Pentagonal prism. And then last one, we'd call it a hexagonal prism. So again, we name the prism based on what the base is, what shape the base is. Okay, so the first thing that we're going to look at is the base area of these. So if you look carefully, this rectangular prism, this is the base and this is the base, and they're identical. So when you're finding their area, it doesn't matter which one you look at. In the rectangular prism, if this length is 4, then I know that this length is 4. And if this length is 8, then this length is 8. So to find the base area, it would be just 8 times 4 because it's a rectangle. So 8 times 4 is going to give me 32. Its area, so it's a square. It's a second dimensional figure, so square units. Okay, so now we have a regular triangular prism. It says it's regular, which means that these right here are equal to each other. And so all of them are 10. Okay. All right, so now we've got to find the area of that base. So we have an equilateral triangle because that's what a regular triangle is. So we have 10, 10, and 10. We know when we drop an altitude in an equilateral triangle, it's going to give us a 30, 60, 90 triangle. So this length here would be 5. And so then the height would be 5 root 3. So to find the area of the base, we would do base times height over 2 because it's a triangle. Okay. And so our base is 10, our height is 5, and we divide that by 2. Which is going to give us a base area of 25 meters squared. Okay, so the last one, so you might have to use the area of a rectangle. You might have to use that triangular area formula. And the last one's a hexagonal prism, but it says it's regular. Now, we don't have a formula for a hexagon, but we do have a formula for a regular polygon. So as a reminder, the area of a regular polygon is the apothem times the perimeter all over 2. Okay, so I'm going to look at the area of this base. And I know that this length is 4 because each of the side lengths is 4. When I put in my center and I drop an altitude, remember that in a hexagon, all of the central angles are 60 degrees. So that whole central angle is 60, so it makes this little piece 30. And that's 60. All right, so that 4 gets cut in half. So it's 2 right here. And so the apothem would be 2 root 3. All right, so then I plug everything into my formula. The area of the base would be the apothem, so 2 root 3 times the perimeter of the base. P is the perimeter of the base. So we've got 1, 2, 3, 4, 5, 6 sides. So 4 times 6 is 24 divided by 2. All right, now we've talked about how it's much easier to simplify before you multiply. So I'm going to simplify that 2 into the 24, which gives me 12. And then I've got 12 times 2 root 3, which gives me an area of the base of 24 root 3. Okay, so we're going to save that triangle, that last triangle, for class tomorrow. Let's look at lateral area. Okay, so we just did the base area. So to define lateral area, we really need to know what the lateral faces are. In a prism, the lateral faces are always rectangles. So looking at those pictures we just worked with, you can see that's a rectangle. The sides are rectangles. These are considered their lateral faces. And I'm going to show you why this is true tomorrow in class. But to find the lateral area, we use the variables LA, we'll say LA. To find the lateral area of a prism, we do perimeter of the base times the height. So let's define that. P is the perimeter of the base. And H is the height of the prism. Okay, so if looking at this first rectangular prism, I see that this is 8, 4. To find the perimeter, I would do 8 plus 8 plus 4 plus 4. I add up all the sides, which is going to give me 16 plus 8, which is 24. All right, so my perimeter is 24, and the height of the prism is the distance from the two bases. So it's the perpendicular segment connecting the bases. So the height would be 5. So I'm going to do 24 times 5 to get my LA. LA is 24 times 5, which is 120 meters squared. It is area, so it's two-dimensional. All right, let's look at that regular triangular prism. If it's a regular triangle, that means all the sides are 10. All right, so I have to get the perimeter of the base. So I'm going to multiply 3 times 10 and get 30. The height of the prism is the perpendicular segment, so one of the edges connecting the two bases. So my height is 50. So I multiply my perimeter times my height. So 50 times 30, which is 1,500 meters squared. All right, looking at that regular hexagonal prism. To find the lateral area, we're going to do the perimeter of the base. So we have 6 sides of all of length 4. So the perimeter of the base would be 6 times 4, which is 24. The height of the prism, again, the perpendicular segment connecting the bases. It's always going to be the edge of the prism. So the height would be 12. And so we do 24 times 12. Okay, so 24, I'm going to do 24 times 12 on the side, which gives me 288. So my lateral area, meaning the area of all the sides, is 288 feet squared. All right, so now we just got the area of the base in the earlier example, the base area of one base, and we just got the lateral area, so the area of all the sides. So now I say, what about the whole surface area? Well, couldn't we take that lateral area that we just found and add to it the area of both bases? The bases are identical. So we can say that we take the lateral area and add to it 2 times the area of the base, a big B. So that is the formula to find the total surface area or total area of a prism. All right, so let's make sure we understand our variables. So LA means lateral area, which is perimeter times height, and then a large uppercase B in math is going to refer to the base area. The base area. Okay, so let's do this. We've got to find the total area of the prism. So I'm going to write total area equals LA plus 2B. All right, we calculated our lateral area by doing perimeter times height in the earlier example, and we got our lateral area to be 120 meters squared. Plus, we calculated the area of the base, and the area of the base was 32, right? In that first example, 32 meters squared. So we're going to put in 32, but we have to multiply that by 2 because there's 2 bases. So 120 meters squared plus 64 meters squared is going to give me 184 meters squared. And that would be the total surface area of the rectangular prism. All right, let's do one more. The regular triangular prism, again, the total area or the surface area is the LA plus 2B because it's got 2 bases. All right, we calculated our lateral area, and our lateral area was 1,500 meters squared. Okay, so 1,500 plus 2 times. All right, let's look back. The area of the base we calculated was 25 meters squared. That base area on page 1. So 2 times 25. We multiply 2 times 25 and we get 50. So 1,500 plus 50 is going to give me a total area, so TA, total area of 1,550 meters squared. Okay, we are going to do the regular hexagon tomorrow in class. Actually, what I want you to do, why don't you try the regular hexagonal prism now and bring it, and we'll go over it in class. Okay, so the last thing that we want to go over in this section is the volume. So we've just been talking about area, and remember, area is a 2-dimensional figure, but volume, when we're talking about volume, it's how much we would fill a figure with, okay? So fill it up, filling it up. So volume is actually 3-dimensional because it has to cover all of the dimensions to be able to fill up a figure. All right, so the altitude or the height of the prism, like we talked about, is still going to be an edge, okay? It's the distance between the bases. It's the perpendicular distance between the bases. Now, for all the prisms that we're going to talk about in this class, they're going to be called right prisms. There are prisms that are actually slanted. We are not going to be discussing anything that's not straight up and down. Okay, so how do we find the volume of a prism? To find the volume of a right prism, we take the area of the base, so big B, times the height of the prism. Again, remember that big B means base area, and H is the height of the prism. The height of the prism. All right, so let's look at the first one. If I want to find the volume of this rectangular prism, I'm going to do base area, so volume equals base area times the height. All right, the base area we already did was 8 times 4, which is 32, right? So 32, and then a height of 5, So 32 times 5 is going to give me 160. But because it's volume, it means it's three-dimensional. So it would be meters cubed. Okay? All right, let's try this rectangular triangular prism. Again, the volume formula is the base area times the height of the prism. I know my height is 50, but again, it's multiplication, not addition. And the base area that we had come up with was 1,500, I believe, right? 1,500. So we multiply. Now, as it, that little trick we talked about in class, I don't have to worry about all those zeros. If I multiply 15 times 5, okay, so 15 times 5, I'm going to get 75. And I have 3 zeros, so I need to add 3 zeros. So my volume would be 75,000 meters cubed. All right, guys, so that's our lesson on surface area and volume of prisms for today. Tomorrow we are going to be practicing this in class. Thanks so much. Have a great night.